Yes, welcome students. Today we want to look at how you can use matrices to solve simultaneous equations, right? And here we're given a problem to solve where we have a pair of equations where 3x minus 4y is equal to 1 and we have 7x plus y is equal to 23. Of course, we have to put this in matrix form, so we're going to need our brackets, right? And what we're normally told to do is to put the coefficients on the left hand side of both equations in the bracket. So we're going to have, for the first equation is 3 and minus 4. These are the coefficients. Coefficients are just simply numbers before the variables, before the letters, right? So we're going to have 3 right here. We're going to have a minus 4 right here. And for the second one, we're going to have 7 and a 1. There's a 1 in front of the y. It's an invisible 1, but it's still a 1, right? And of course, we're going to have, we're going to put our x and y. And we have one more bracket, which contains 1 and 23, right? 1 and 23. Okay, now let's call this A, matrix A, right? The goal is to find the inverse. The only way we can solve for x and y is if we find the inverse of this. But first we must find the determinant. The determinant is represented by the symbol. It's like a triangle. So the determinant of A, our first step is to multiply the leading diagonal by the other diagonal. So it's going to be 3 times 1. 3 times 1, and then we're going to subtract the other diagonal from it, right? So it's going to be 7 multiplied by minus 4. This is going to lead to 3 times 1 is 3 minus 28. And of course, when two signs of the similar, two minus signs face each other, it becomes a plus. So this is going to be equal to 31. So 28 plus 3 is going to be 31. So the determinant is equal to 31. Now we have to find the adjoint now. The adjoint moves from, so we have the original matrix here, 3 minus 4. This is original matrix, 7. It's going to move to the adjoint now. So we're going to reverse now the leading diagonal. We're going to reverse the positions. So we're going to put 1 up here and 3 down here. We're going to also reverse the signs. We won't reverse the numbers. We're going to just simply reverse the signs. So this is going to become minus 7. This will become and it's going to become 4. So this is now the adjoint. Now that we have the adjoint and we have the determinant, to find the inverse, which is represented by this symbol a to the minus 1, that's going to be, we're going to multiply now, or we're going to divide this by this. So it's going to be 1, 4, 9 minus 7, 3 divided by 31. And so or we could put it this way, we could put 1 over 31 multiplied by 1, 4 minus 7, 3. Either way you want, we're going to get the same results, right? So this is going to be equal to what? This is going to actually lead to, so the inverse is going to become 1 times this would be 1 over 31. 4 times that would be 4 over 31. Negative 7 times this would be negative 7 over 31, and 3 times this would be 3 over 31. So this becomes our inverse. Right? Now, what are we going to do with the inverse? What are we going to do with this? We're going to pre-multiply it. We're going to put this inverse. Somehow we're going to put it into this. We're going to put it before this, and we're going to put it before this. We're going to pre-multiply it. So we're going to have the inverse now is going to be solved. So the inverse is going to go here. And remember the inverse was 1 over 31, 4 over 31, negative 7, I think, over 31, yes, if I can recall. And then we have 3 over 31. So it's going to become before the original matrix, which is 3 minus 4, 7 and 1, right? We're still going to have our xy. We're going to bring down the equal sign. We're going to put the inverse right here again, because we're pre-multiplying on both sides, right? We're going to pre-multiply on both sides. So we're going to have our 1, and we're going to have our 23 down here, just the same, right? We're going to insert the inverse right here, which is 1 over 31, 4 over 31, minus 7 over 31, and 3 over 31. It's a bit lengthy to multiply this out, but I'm still going to do it just the same for you to understand what's really happening here. So 1 over 31 times 3 is equal to 3 over 31. Plus, this times this is 28 over 31. 7 4 is 28. And that's going to equal to what? That's going to equal to 1. So we see now basically that we're trying to create the identity matrix, because when you multiply the matrix by its inverse, you're going to get the identity matrix, right? So the first one is 1. We're going to go for this column now, right? So 1 times minus 4 is minus 4 over 31, and 4 times this, 4 times 1 is really 4 over 31. When you add these two, you're going to get 0, right? So 0 comes here. We're trying to prove to you that when you multiply the matrix by its inverse, you're going to get the identity matrix, right? Now, the other stage, now we're going to multiply this row now by here and here to get both values. So negative 7 times 3 will be a negative 21 over 31. And 3 times this, so this times this would be 21 over 31 plus. And this is going to be equal to 0. So you put the 0 right here. So go back again for the second column now, where we get negative 4 times negative 7, it will be a negative, which will be a positive 28 over 31. And we're going to have 3 this times 1 now, which will be 3 over 31 plus. And that's going to equal to 1, because 3 plus 28 is 31 over 31 gives you 1. So here is 1. So when we work this out, we produce the identity matrix. We'll still bring down our xy, and that's going to be equal to this times this. Now let's work this out now. That's going to give us a final matrix value over here. So we're working out this now. This times this is 1 over 31 plus 4 times this, which is what now? 4 3 is 12, 4 2 is 92 over 31. And that's equal to what? That's equal to 93 over 31, and that's equal to 3, right? Because when you divide this into this, you're going to get 3. So our first number here is going to be 3. For the second one, we're going to multiply this by this and add it to this times this. So this will be negative 7 over 31 plus this time this will be 3 times 3 is 9. 3 3s is 9, 3 2 6. 69 over 31. And that's going to be equal to 62 over 31, which is equal to what? Which is equal to 2. So we find now that 1001 times xy is equal to 3 2. Now remember that this identity matrix is really 1. So in actual fact then, we're going to just simply bring down the x and the y to equal to 3 and 2. So corresponding values. So x corresponds with a 3 and the y corresponds with a 2. So therefore we could say x is equal to 3 and y is equal to 2, and we would have solved the problem right here just by simply using the matrix. We can use the matrix to solve simultaneous equations. Remember to make your comments. If you still don't understand, just go right through back the video, revisit the video and look at it again over and over until you understand the principle, right? Remember to subscribe and like. Thanks for watching, all right?